Hello and welcome to Algebra 1C 7.1 Notes. We are beginning the polynomials unit, so today we are going to learn a little bit of vocabulary so we know what we're talking about and how to add and subtract polynomials. So the first thing we need to know is, what is a polynomial? Well, a polynomial is an expression that has any number of terms. The exponents must be whole numbers, which means things like 1, 2, 3. That means no variables, no fractions or decimals, no negatives. Terms is a term, a vocabulary term that we just used. So if a polynomial can have any number of terms, what is a term? A term is an expression separated by addition or subtraction. So in this example over here, we have one term, two terms, three terms. So these are our terms. Right? It's 4x squared, that's our first term, plus 3x, that's our second term, minus 7, that's our third term. So we need to be able to count terms in a polynomial. Like terms are terms that have the same variable to the same power. So we've seen these before. That's things like 3x plus 2x. Those are like terms, and we know that we are able to combine like terms. That's going to be part of our simplifying process. So if I saw two like terms, I could combine them by adding the coefficients. Standard form is a really important vocabulary word to know. So standard form is arranging the terms, we just talked about what a term is, in descending order of variable exponent. Typically, the variables are done alphabetically, but this would be like if I had 2x to the third, then I would have, maybe 5x squared. So see, the variable exponents, or the exponent on the variable, they're counting down. So it's descending. So this could be minus maybe 6. So something like that, that would be in standard form, because we have x to the third power, x to the second power. This is technically x to the first power. And this is technically x to the 0 power. Okay. So degree, right? So we just talked about the variable exponents. We refer to that as the degree. So if I was talking about this exponent, this polynomial example I just did, this would have a degree of 3 because it's the largest exponent. When it's in standard form, which we just wrote that in, it will be the first term exponent. So 2x to the third is my first term. So that would be that first term's exponent. So that's how we can find that easily if it's in standard form. That's part of why we write these polynomials in standard form. Coefficient is our next one, which is something that we should know, right? So that's something like if I have 3x, my coefficient is 3. So that's a word I use all the time. It's something that we should know. So if I say, like, add your coefficients for like terms, we're saying add 3 and 2 to make 5. That's adding our coefficients. So that is definitely a word we should have heard before today. A constant is a term with no variable in it, just a numeric value. So that would be, for example, 5, right? Not 5x, just 5. The leading coefficient is, again, when we have something in standard form. So again, that example at the top, if I say 2x to the third plus 5x squared, what is my leading coefficient? Is the coefficient of the first term in standard form. So my exponents are in descending order, so my leading coefficient is 2 for this one. Okay, so that's all the terminology we need to know. Let's start adding and subtracting these polynomials. Oh, just kidding. Let's classify these polynomials. So we classify polynomials two different ways. We classify them by degree and by the number of terms. So degree we talked about. That has to do with the biggest exponent, right? So we're just going to write that here, biggest exponent. And the number of terms, right? So I said before, we need to know what a term is so we can count the terms. This is why. So together we call this classifying polynomials, and there's going to be two tables. You're just going to want to refer to these tables in your notes. You don't need to memorize them, just know them. Just know how to use this table, okay? So the steps first are going to be put the polynomial in the standard form, right? So starting with the biggest exponent and working your way down to there's no exponent or no variable. And then you're going to classify by degree and classify by number of terms by using these two tables. We always classify by degree first and then the number of terms. It'll kind of flow together like an adjective noun. So like the first one talks about the second one. So it'll make a little bit of sense when you say it. So our degree, here's our list on the left, 0 through 5, and then we have anything 6 or more. I have what the name is. So this is actually the chart that we're going to read in the middle. That's going to be our name, our classification name, and then examples of these on the right. So a constant has degree of 0. So this, we talked about what a constant is. It is just a number without a variable. So something like 5, right? So I'm reading right here. Constant is a number like 5. So if that's your whole polynomial, that is a constant. Linear is like what we did all of last semester, right? So linear is something like 5x, or it could be something like 5x plus 3, right? It could have a second term after that that is a smaller degree, which would have to be a constant. A quadratic is something with a x squared, okay? And again, it could be something like 5x squared plus 3 or plus 3x, right? So, or plus 3x plus 3. It could have multiple terms as long as each one is smaller than a degree of 2. All right, so that's true for all of these. Cubic is something that starts with an exponent of 3. Quartic, like quarters, is an exponent of 4. Quintic is an exponent of 5. And then after that, we would say 6th degree, 7th degree, etc., right? So if it was x to the 6th, x to the 7th, x to the 8th would be 8th degree. You just plop in the number and say what degree it is. So for number of terms, we only really have 3 words. And then again, we have one that's just for anything 4 or more. So if we have one term, it is a monomial, right? Mono meaning one. So think like monocle, right? Is one eyeglass, like Mr. Peanut or the Monopoly Man, something like that. Monopoly also, same thing, Monopoly. One person has all the money, okay? 2 terms is binomial, so like a bicycle. 2 terms, right? So you got 1 term, 2 terms, and then trinomial, 1, 2, 3 terms, like a tricycle or a triceratops. After that, if it has more than 3 terms, we would just say a polynomial with blank terms. So in this case, we have 1, 2, 3, 4. So this would be a polynomial with 4 terms. Okay, could be a polynomial with 5 terms or 6 terms, but anything over 3, we just say polynomial with blank terms. So you do have to say how many terms it has, but there's no specific word for those. So let's do a couple of examples down here. So remember, we're going to look at our charts and we have to classify by degree first and then by number of terms. So degree is, if they're in standard form, should always be the first exponent. So degree of 3, if we look at our chart above, this one, whoops, our chart up here, degree of 3 is cubic. Okay, so a cubic, what? How many terms are these? So this is 1, 2 terms, so it is a cubic binomial. Okay, and that's it. That's all of classifying. We just say, what is the degree? Find it on the chart. How many terms are there? Find it on the chart. Okay, it's all about using that chart. Okay, the second example here, this is one we're going to see a lot, right? So this one starts with a degree of 2, right? If we look at our chart above, degree of 2 is a quadratic. So that's our first one, quadratic. And then 1, 2, 3 terms. So it is a trinomial. Okay. And if I look at number 3, so we're going to look at number 3 next. This one is not in standard form, right? So if I just looked at my first term, I would say, oh, this is linear, but only the first term is linear. It's not the degree of the whole polynomial. So the first thing I want to do is just rewrite this so it's in the standard form. So I'm going to start with my biggest exponent, so 7x to the 4th. And then we're just going to count down. So do I have anything to the 3rd power? Yes, I have 6x to the 3rd. So we're going to do that next. And then negative 3x squared. and then x, and then minus 5. All right, so there's all my terms put in order. So now I can say that this one is a quartic because it starts with a degree of 4. And it has 1, 2, 3, 4, 5 terms. So it's a quartic polynomial with 5 terms. So make sure you include that last part about the 5 terms at the end. We're good to go. Okay, next one, 2x plus 3. So again, we're starting with our first term here. It's in standard form. So 2x is a tricky one because I don't see a number there, right? But we can look at our table. We can find the one that looks kind of like that, right? This is really a degree of 1 because it's really 2x to the first power. So this one is linear. And this one also has 2 terms just like our first one, 1, 2. So it's a linear binomial. Binomial, it's not writing. They're a linear binomial. Okay, let's move on to adding polynomials. So we have our steps here, which say, for adding, we can basically ignore the parentheses and just combine like terms, and then write that polynomial in standard form. So one of the things I like to do here is just start with the biggest exponent and work our way down, so that when we're done, our polynomial will always be in standard form. We don't have to then rewrite it again. So let's do that. Let's take a look at the whole problem before we get started. So if I look at number A, we have 2x to the third plus 5x. That's our first polynomial, as you can see by the parentheses. Plus, right, so that's our sign in the middle that tells us what we're doing. Plus 3x minus 6x to the third. That's our second polynomial. So I'm combining polynomial 1 and polynomial 2. We can see in both of these polynomials, right, our biggest exponent was x to the third power. So we're going to start by combining 2x to the third and negative 6x to the third. So remember, to combine like terms, all we have to do is add the coefficients. The variable is just going to stay exactly the same. We're just counting. What are we counting? X to the thirds. So 2 minus 6 is negative 4. So we have negative 4x to the third. And then just to be safe, I just like to count down. So if that was x to the third, we're going to talk about, or we're going to look for anything with x to the second, which I don't see. X to the first, which I do see, right? So we're going to count our 5x plus 3x is 8x. So plus 8x. And that's our last 2 terms, right? So we don't have a constant term, which would be my next one, right? 0 x's. So that is our answer, and it is already in standard form because I started with my biggest exponent and worked my way down. Okay, let's look at our next one. Same idea. 4v minus 2v to the third minus 3v to the fourth. That's all my first polynomial. Plus 1 plus 8v plus 4v to the third. That's my second polynomial. So again, let's find our biggest exponent. And our biggest exponent is this one right here. So we have negative 3v to the fourth plus nothing, right? We don't have anything to combine that with, so we're just going to put that one first. Then we're going to cross that out. So now we're going to look for anything with v to the third. So here's negative 2v to the third plus 4v to the third. So negative 2 plus 4 is positive 2, v to the third. Then I'm going to look for anything v to the second power. I don't see anything. So then we look for anything that's just v, and I see 4v plus 8v is 12v. And finally, I just have my constant plus 1. So there it is. We are finished adding our like terms, and our answer is in the standard form because we started with the biggest variable exponent and worked our way down. Okay, now let's talk about subtracting. Subtracting is a little bit trickier, but it's okay. we'll be fine. So it's got a little extra step here. The first thing we're going to do is distribute the negative. Change all the signs of the second polynomial. Then we're going to combine like terms and write our polynomial in standard form. So those last two steps are exactly like adding, but we have to deal with this negative sign that we're distributing in for our second polynomial. So let's see what that looks like. So let's look at example C. We have a squared minus 3 plus 3a to the third minus, so this is our second polynomial. We're subtracting this whole thing. So first polynomial minus the second polynomial. So I'm subtracting 6a to the third, negative 5, and 7a squared. I'm subtracting all three of those terms. So the first thing I'm going to do is rewrite my first polynomial exactly as it is. And then we're going to distribute. So this is going to be minus 6a to the third. Minus negative 5 becomes plus 5. And minus 7a squared. So just distribute that negative, which effectively just changes all the signs inside those parentheses. Okay, that's our first step done. So now we just have to combine like terms. So do you guys remember how to make this? Oops, this would have been a to the third. Our way to make this as easy as possible is we're going to start with our largest exponent. So scanning my original problem, I have a to the third power, right? So I'm going to find everything with a to the third power, which is those two. So 3 minus 6 is negative 3, a to the third power. And then we have negative 7a squared. I also see this is technically plus 1a squared. So 1 minus 7 is negative 6a squared. I don't see anything that's just an a, so our last two terms are going to be negative 3 plus 5, which is positive 2. And there we have a cubic trinomial, which is our answer in standard form because we started with the biggest exponent. Okay. Example D, same idea, okay? X to the third minus 2x squared plus 5 minus x to the third plus 5x minus 7. So we're going to distribute this negative to all of these three terms. So this positive x to the third has become a negative x to the third, positive 5x becomes a negative 5x, and negative 7 is going to become positive 7. So I'm just going to rewrite all those. So these first three terms, the first polynomial stays exactly the same. Now this is going to become minus x to the third minus 5x plus 7. And now we can combine our like terms. So biggest exponent is 3, so we're going to start with x to the third minus x to the third. Well, those cancel out. They leave nothing, right? So there is no x to the third. Next one is negative 2x squared. And that's the only one I have, right? So we're just going to put that out front. Just write it down. Now we're going to go to our x's, right? I see one x, which is negative 5x. That's our 1x term. Okay, and then finally our constants. So then we have 5 plus 7 is 12. And that will leave my answer as a quadratic trinomial in standard form. Okay, for these ones above, it asks us what is the leading coefficient. So let's do C. I'm going to switch back to blue. I was going to say for C, what is our leading coefficient? So our leading coefficient is the number in front. Because we put these in standard form, I can just look at that front number. So our leading coefficient is negative 3. The degree of this polynomial is 3. And then we're going to classify it. So it's a cubic because it's degree of 3. So cubic. And it has 3 terms also, 1, 2, 3, trinomial. So that is our classification for that one. For D, our leading coefficient is negative 2. The degree of this polynomial is 2. Okay, so then when we classify, right? So if it just asks us what the degree is, we can put the number. When it asks us to classify, we need to use the fancy word. So you can use that number 2, right, to find on your chart what is a degree of 2, and we would find that it's a quadratic. And then how many terms is it? 1, 2, 3. So that is a trinomial as well. So these were both trinomials, but one was a cubic trinomial and this one was a quadratic trinomial. Okay, and that's your notes.